Okay, picture this. An AI assistant. One that can actually learn to do new things online,
Right.
like booking flights or, researching products.
Right.
But the thing is,
Yeah.
without needing like step-by-step instructions for every single task,
Yeah.
that's the future that
Wow.
researchers are working towards.
Hmm.
And it's all because of this thing called PAE,
Hmm.
Proposer Agent Evaluator. And we've got a paper here that breaks it down. It's pretty dense stuff.
Oh, yeah, those can be tough.
But luckily, we've got an expert here to help us unpack it.
I'm happy to help. PAE is really interesting, because it gets at
Yeah.
how we might build truly intelligent agents
Okay.
that can operate in the real world, specifically the internet.
Right. Because teaching an AI to browse the web like a human, I
By the
mean,
way, yeah.
that's not easy.
No, it's a huge
It's a
challenge.
huge feat. We can't just like hand it a rule book
Yeah.
for every website and every possible scenario.
It's too many.
There are just too many.
Way too many.
So many.
That's the challenge that PAE is trying to address.
Okay.
So instead of relying on tons of labeled data where humans have to
Right.
painstakingly show the AI what to do
Yeah.
for every task, it lets agents learn through a sort of self-directed practice, with feedback along the way.
So it's like giving the AI the tools to learn on its own rather than trying to program every bit of knowledge into it.
Exactly. And that's where the three parts of PAE come in: the task proposer, the agent policy, and the autonomous evaluator.
Okay, let's break that down. What's the task proposer's role in all this?
So the task proposer is like the brainstorming buddy for the AI agent.
Okay.
It suggests tasks for the agent to try out, and surprisingly can often do this with very little information.
Really?
Sometimes just the name of a website is enough.
Wait, just the name. How does that even work?
Okay, so the task proposer is powered by what we call foundation models.
Okay.
These are massive AI models that have already been trained on huge amounts of data. They kind of have a broad understanding of the world, including things like what people typically do on certain websites.
Okay.
So if you tell the proposer, Amazon.com,
Right.
it can tap into that knowledge and suggest tasks like find a specific product or compare prices.
So it's using common sense and its existing knowledge to come up with relevant tasks. That's pretty neat. But what about more complex websites? Ones that these foundation models might not know as much about.
Right, so for those cases, we can give the task proposer a bit more context, like a few screenshots of the website.
Oh, okay.
That gives it a better sense of the layout
Right.
and the kinds of actions a user might take.
Got it. So the task proposer kind of sets the stage.
Uh-huh.
Then what happens?
That's where the agent policy comes in.
Okay.
This is the AI agent itself, the one actually carrying out the tasks.
Right.
To make it really good at transferring skills to new situations, it's designed to think out loud as it works.
Think out loud. You mean it literally explains its reasoning?
Exactly. Before it clicks a button or enters text, it generates a little text explaining why it's taking that action.
Wow.
Yeah, this helps the system understand
Okay.
not just what it's doing, but why.
That's fascinating.
It is.
It's like giving the AI a way to articulate its thought process. It seems like that would be really helpful for learning. So the agent tries a task, explains its thinking, then who grades its performance?
That's the role of the autonomous evaluator.
Okay.
This component judges whether the agent succeeded at the task.
Okay.
And here's the key. It does this based solely on the final outcome, not the agent's internal thought process.
So it's like a pass-fail exam, no partial credit for effort.
Pretty much.
Yeah.
It might look at the last few screenshots of the web session and compare them to the task description.
Right.
This forces the evaluator to focus on results. Did the agent actually achieve what it was supposed to do?
That makes sense. So it's a cycle. The proposer suggests the task, the agent tries it while thinking out loud, and the evaluator judges the result. But where does the learning happen?
That's where the magic of reinforcement learning comes in.
Okay.
Based on the feedback from the evaluator, the agent adjusts its behavior over time.
Okay.
Think of it like training a dog with treats.
Right.
If the agent gets a thumbs up for completing a task, it's more likely to repeat those actions in the future.
So it's like a continuous feedback loop.
Yeah.
With the agent getting better and better at web browsing through trial and error.
Exactly.
Oh.
Now, here's where things get really interesting.
Oh.
The researchers found that this system actually works. They tested it in 2 simulated web environments,
Okay.
and the results were pretty remarkable.
Okay, I'm definitely intrigued. Tell me more about what they discovered. What were these AI agents actually able to do?
So they tested the PAE system in 2 different web environments.
Okay.
One called Web Voyager used real-world websites like Amazon and ESPN.
Oh, cool.
The other web arena used a set of custom-designed websites.
So the AI agents were tackling tasks like finding products on Amazon or looking up scores on ESPN. That sounds pretty close to what humans do every day.
Right. And they found that the agents trained with PAE
Hmm.
were able to do new tasks,
Hmm.
not just on familiar websites, but also on completely new ones they had never seen before.
So they weren't just memorizing specific steps, they were actually learning how to navigate the web in a more general sense.
Exactly. They seem to be developing a real understanding
Wow.
of how websites work, for instance.
Yeah.
In one example, an agent had to find a specific feature on GitHub.
Okay.
It started by looking for a direct link
Uh-huh.
on the homepage.
Right, just like you or I might do.
Right. But when it couldn't find that link, it did something really interesting.
What happened? Did it just give up?
No, not at all. It actually opened a new tab, went to Google, and searched for the feature it needed.
Wow, that's impressive. It's like it figured out that Google is the go-to tool when you can't find something directly on a website.
It really does seem that way. It suggests that these agents are learning
Yeah,
more than just a set of instructions.
right.
They're starting to grasp the underlying logic of the internet.
Were there any other examples of this kind of problem solving where the AI agents did something surprising or unexpected?
There were several. In another case,
Yeah.
an agent had to complete a multi-step task
Okay.
that involved finding a product on Amazon,
Right.
then comparing its price to a similar product on Best Buy.
So it had to jump between different websites and remember information from each one.
Yes, and it managed to do it successfully, even though it had never seen a task exactly like this before.
Wow.
It had learned how to navigate Amazon and Best Buy individually.
Okay.
And then it was able to combine those skills
Hmm.
to solve this new, more complex challenge.
That's really remarkable. It suggests that this PAE system is enabling agents to go beyond just rote memorization and actually reason about tasks and apply their knowledge in flexible ways.
I agree. It's a very promising step towards creating AI
Yeah.
that can handle the kinds of open-ended,
Right.
unpredictable tasks that we humans do effortlessly.
But let's be realistic. No AI system is perfect. Did the researchers encounter any situations where these PAE agents failed or struggled?
Of course, there were some limitations. The researchers found that agents sometimes had difficulty with tasks that required a very specific sequence of actions.
Oh, okay.
Where one misstep throws off the whole process.
I see. So like following a complex recipe where the order of the steps is crucial?
Exactly. In those cases, the agents might benefit from more guidance, perhaps a more nuanced reward system that acknowledges partial success.
It seems like a more sophisticated feedback system.
Right.
Could help the agent learn more effectively in those situations.
That's one area researchers are exploring. Another challenge is dealing with dynamic websites that change their layout or functionality frequently.
Right. The internet is constantly evolving. It's a moving target for any AI trying to learn how to navigate it.
Precisely. Future research will need to address how to create agents that can adapt to these changes and continuously learn.
It sounds like there's still plenty to figure out, but these results are incredibly exciting. What stood out to you as the most surprising or intriguing finding from this research?
What I find fascinating is that PAE seems to be tapping into something fundamental about how intelligent agents learn.
Uh-huh.
It's not just about, giving an AI a huge data set.
Right.
It's about creating a system where the AI can learn through its own exploration and experimentation.
So providing a framework for learning rather than trying to program every single detail into the AI.
Exactly. And this approach could have profound implications. Imagine a world where we can create AI agents that can not only browse the internet, but learn to code, design, write, even conduct scientific experiments.
The possibilities are both exciting and a bit daunting.
Absolutely. But before we dive into those broader implications,
Yeah.
let's come back to the details of this PAE system.
Okay.
We mentioned earlier that there were some intriguing findings about the task proposer and the evaluator,
Right.
particularly in relation to the agent's performance. I'm curious to learn more about that.
Yes, let's unpack those details. It sounded like there were some surprising discoveries about how these components influence the agent's learning. Okay, let's talk about the task proposer and the evaluator. I'm curious about those intriguing findings you mentioned. What was so surprising about them?
Well, one of the most interesting discoveries was that the PAE system worked well even when the AI models used for the task proposer and the evaluator were, significantly smaller and less complex than the model powering the agent itself.
So the teachers, so to speak, weren't as sophisticated as the student. That's counterintuitive.
It might seem that way,
Yeah.
but think about it like this. The task proposer doesn't need to be a genius to be effective.
Okay.
Its main job is to suggest tasks that are challenging enough for the agent to learn from, but not so difficult
Right.
that they become impossible to solve.
So it's more about providing the right level of challenge rather than spoon-feeding the agent all the answers.
Exactly. And when it comes to the evaluator,
Yeah.
the researchers found that a simple, outcome-based approach worked best.
Mm.
The evaluator just focuses on whether the agent achieved the desired result without getting bogged down in the details of how it got there.
It's like saying, I don't care how you did it as long as you got the job done.
Yes, precisely. And there's a good reason for this.
Okay.
More complex evaluators, ones that try to analyze the agent's every step, can be prone to errors.
I see.
They might misunderstand the agent's actions or misjudge whether a particular step was, helpful or harmful.
It makes sense. A simpler evaluator is likely to provide more consistent and reliable feedback, which is crucial for the agent's learning.
Right, so the surprising bit, as you called it earlier, actually makes a lot of sense when you consider the dynamics of the system as a whole.
This whole idea of a less sophisticated task proposer and a simple evaluator successfully training a more powerful agent.
Yeah.
It really challenges some of our assumptions about intelligence. What do you think this tells us about how we might build truly intelligent AI?
Well, this finding raises an important question about the fundamental ingredients of learning and intelligence, PAE, suggest that raw processing power and massive data sets
Yeah.
aren't the only things that matter.
Right.
Creating the right learning environment, providing clear and consistent feedback, and allowing for, self-directed exploration are crucial as well.
So it's more about fostering the ability to learn than simply stuffing an AI full of information.
Yes, I think that's a key takeaway. And if we can, crack the code of how to build AI that can learn autonomously, adapt to new situations, and solve complex problems, the possibilities are truly mind-boggling.
Imagine AI agents that can not only browse the web, but learn to code, design products, write music, conduct scientific experiments.
It's a future that's both exciting and a bit daunting, isn't it?
Absolutely. And for listeners who have joined us on this deep dive, what are the most important things you'd like them to take away from our discussion?
I think the key takeaway is this.
Yeah.
We may be on the verge of a major paradigm shift in AI.
Hmm.
One that moves us beyond systems that can only do what they're explicitly programmed to do.
Okay.
We might be entering an era where AI systems can learn, adapt, and solve problems
Wow.
in ways we never thought possible.
This PAE research is a fascinating glimpse into that future. That's a lot to think about.
Indeed it has.
Thanks for joining us on this deep dive into the world of self-learning AI. We'll continue to keep an eye on these developments and bring you more insights as they emerge.